Hi everyone, myself Ramesh. Today I am going to solve an spiral matrix lead code problem. It's a medium problem. Let's jump to the problem statement. Yeah, here is the problem. So in the lead code, medium level problem. So the problem statement says, given an positive integer n and generate an n by n cross n matrix filled with the elements from 1 to n square in spiral order. It is the key point here. We have to fill the matrix n by n in the spiral order. So, to understand it, let's go to the some examples. So for n equal to 3, 3 cross 3 matrix, so we will be having 9 cells. Oh, total we will be having 9 cells. We have to fill these 9 cells in the spiral order from 1 to n square, means 1 to 9. For the n equal to 3, 1 to 9 we have to fill up. So for the first cell, 1, second, 2, 3. Now once we are done with the right traversal, we have to go down till the all the rows are completed, like 4, 5. Then we have to go left 6 and 7. Then up top 8. Then 9. This is the spiral traversal. The output we should return is an n cross n matrix with by filling all the elements in the given order in the spiral order. So yeah, and let's understand this with another example, like n equal to 4. So here is the I have drawn the 4 by 4 matrix. So how do we fill it up in the spiral order? For the 4 by 4 matrix, we will be, let's say, we will start at the 0, 0 comma 0 cell. So we will fill it with 1, and we will travels to the right, and we will fill the with 3 and 4. Once we are done with the first row, we need to travels to the down at the last column. So like 5, then 6, then 7. Now we are done with the last column. Now we have to travels again last row, 8, 9 and 10. Now we are done with this one. We have to fill up this ones together. Next, now we are done with the outer the spiral traversal. There is still we have the 4 cells left with. Now we have to do the again the same way, like the right direction, then down, then left, then top. Now if we come up again, fill up the um, 13 and 14, 15 and 16. This is the uh, this way we have to fill up the 4 by 4 matrix. So and if we go to the 4 by 5 matrix like this, if the key observation is, now we, if we are at the cell of 0 comma 0, we have to traverse to the right until we get the last column, right? We should leave the last column, just we have to traverse up to the um, um, but one last column. So once we are done with this filling up, now we have to start with the last column and fill up all the rows until again the last row. We should leave this ones. Then we have to traverse again the last row and fill these cells. Then we have to go from here to here. So once we like this, we will be done the outer one. Then we can go to the inner one. Like again, we have to traverse from here to the here, and we will leave the last one, and down, then left, then right. These are the observations for this problem statement, right? Yeah. So Let's take down the observations again. First, we need to return the output as the matrix, right? Output as n cross n matrix and each matrix we have to fill up with the spiral order. So here one more observation we can make it that how many traversals required for n by n matrix. So if we keep observing, so for the 3 by 3 matrix, there will be the two spiral. One will be the outer one, and the second one will be the inside. If it is 4 cross 4 matrix, there will be the, as we shown here, uh, there will be outer one, then inside this another one. So for any n cross n matrix, the number of spiral traversals required is n by 2. And for the like base, odd numbers, we have to take the upper value like n by 2. For in this case, if it is the n equal to 3, 3 by 2 it will come as the 1.5. We have to take the upper value like 2. So 2 traversals are required. For n equal to 4, 4 by 2 is 2, so we will be required 2 traversals. Let's say like if n equal to 10, 10 by 2 is 5, so there will be 10 of 5 traversals required. So that is the one more observation. So we have to calculate the number of spiral rotations, and for each rotation what we have to do is we just need to follow 4 steps. One is we have to go to the right side, then we have to go to down side, then we have to go to left side of it, then top. These are the for each rotation we have to do. So let's calculate the number of spiral rotations we get. It's simple, like we just need to calculate the rotations count equal to like n by 2, but we have to take the upper value. So like math.ceil is nothing but the upper value, so we are just taking the number of rotations. Now for each rotation we have to, these 4 steps we have to do, right? So let me just do the for each rotations, like r equal to 0 to r is less than rotations count r plus plus. Now we got the each rotation here. We have the rotation 0, rotation 2, like that, rotation 1 and like that. So for that we have to do this. First one we have to traverse to right side, then down side, then left, top, right. So first let's start with the right side. So where we have to start is the number of the rotations. If the rotation is 0, we have to start from 0 comma 0. If the rotation is 1, we have to start from 1 comma 1, like that. If it is rotation 2, that we will travels from the 2 comma 2. So let's take another 2 variables which are helpful for traversing the rows and columns. So for I, we have to start from uh, whatever the rotation we have. Like if it is 0th rotation, 0 comma 0 we will be having. Now we are at the 0th rotation, means 0th row. Then we have to traverse entire row except the last one, right? So means we are just keeping the row is same, but column will be changing. So let's say j is the column representative, so we will traverse the j until last column, but we have to leave the number of rotations also. So we will less than the last column, but for first rotation we will decrease the 0, and for the second rotation we have to leave the last column again. That's why we have to do the minus of rotations count. So for the for example, if the rotation count is 0, we will travels from 0 comma 0 to last one except the last one and before one. So just we have to do the plus plus. Now we will fill up our output. Sorry, let's before this let's have the output array where we need to fill up this. So I'm just taking an n cross n matrix. So this will just create an output matrix, but without filling any details. It just creates the matrix. Now we can fill up it with our required values. And uh, let's take another variable here which will require for the filling up. So output of ij equal to k plus plus. So what, let's say for example, the I will be the zero for the rotation 0, we will be having I will be the 0 and j will be the 0. It means first row, and j will go from 0 to n minus 1 minus r, means n will be the 3 in this example. 3 minus 1 means 2. 2 minus 0 means 2. Less than 2 means 0 to 1. Then we will fill up 0 0. Then next we will fill up 0 comma 1. Means these two will be getting filled up with k. So first k will be the 1, then we will be incremented it as the 2, so it will keep on printing. This will fill up as for the right side. Now we have to go to the downside. So we reach this cell now. So from there we have to go to the all the rows until the last one. If it is the zeroth rotation, we have to go to the last row, and if it is one another rotation, we have to leave the last one, and we have to go to up to the second last column, sorry, row. So like that. Now in this case, j will be the fixed one, which is nothing but n minus 1, the last column, and the rows are keep on changing, right? First will be the 0, then 1, and like that. So we incrementing the j until n minus 1 minus r, and we will keep on increasing the this one. Same we will output our I comma j with k plus plus. So now in by this we will getting fill up with the downside. Then we just left with the, we have to traverse the left side. So in this case we have to again start from the last column to the first column, and the here columns will be keep on changing, and the row will be the last one. So while j is greater than, so if it is zeroth one, we have to leave the zeroth one. If it is first rotation, we have to leave the first one. That's why we will keep on increasing until we reach the rotations count. Now same we will do output of ij equal to k plus plus. Now we will just left with the traversing the top side. While so in this top side we are again going with the rows, and rows we should go until the we reach the rotations count, right? Then I is greater than or, then output of I j will be the k plus plus, and we have to decrease the I. So then at the last we have to return our output matrix. So just going through the overview. So first we calculated the number of rotations. So for n by n matrix, we will be traversing how many rotations that will be counted here. Then for each rotation, we are just looking through the number of rotations. For each rotation, we are just going through the right side, down side, left side, and top side, and filling up our output matrix. Like right side, we are just traversing from the uh, 0 comma 02 until the last one, but we will leave the last one so that we can travel to the right side, sorry, downside. Again for the downside also same, and then we will travel to the left side, then top side. This will be the observations. Let me run and check it. Yeah, something we missed up. Yes. So we got the output as 1 2 3 8 4 7 6 5. We just left the 9 is missing. Means in our case 1 2 3 is already getting filled up. 3 4 is 5 is filled up. 6 7 8 is filled up. But only 9 was not getting filled up. It's the uh, base condition. Sorry, corner case we can say. For the odd ones, we won't be getting the middle one. If it is 4 by 4 matrix, we won't be having the middle center element, but for that it will automatically fill up. But for odd number of n's, it won't fill up the exact this center side. For that, we are just writing the, if the rotations, sorry, if n percentile 2 equal to 2, then means odd one. We just need to fill up this exact center one. So output of, so the rotations count minus 1. The center element will be having the number of rotations minus 1. Then n plus, sorry, n into n, which is nothing but the last element. So let me run again, check it out. Yeah, it's accepted now. So if we test with for 4, it should work. Yeah. So we are just filling 1 2 3 4, and this as the order we shown here: 1 2 3 4 4 5 6 7 8 9 10 11 12, and then the second rotation will fill up the 13 14 15 and 16. Yes. So let me submit it, check it out. Yeah, it's accepted. I hope you understand the problem statement and the solution. Thank you.